In the sartrac project, we explore the large-scale physical processes controlling sargassum blooms in the tropical Atlantic. Before 2011, sargassum blooms were mainly observed in the Sargasso Sea, in the western subtropical Atlantic. However, during winter 2010-2011, there was a very strong climatic event, and the wind pattern and the ocean currents associated with this wind pattern changed dramatically in the subtropical Atlantic. And a large amount of sargassum mats were transported from the subtropical region down to south to the tropical Atlantic. Since 2011, there are recurrent large sargassum blooms and associated landing events almost every year. So in this new habitat, the tropical habitat for sargassum, conditions for growth are optimal, much better as compared to the Sargasso Sea. So we have warmer waters, we have better light conditions, solar radiation, and most importantly, we have much higher nutrient concentrations. So physical processes, mainly the winds and ocean currents, have a strong control on the nutrient availability for sargassum in the tropical Atlantic. So we have upwelling regions like the equatorial upwelling region with permanent upwelling of nutrient-rich waters. And in addition, we have very strong river outflows of nutrients, mainly by the Amazon River. So the ocean currents and winds have an impact also on the drift of sargassum across the tropical Atlantic. So a very important region is the intertropical convergence zone, where the winds converge and have an effect on accumulating sargassum in that region. Also, ocean currents transport and drift sargassum from the central West Atlantic, both westbound to the Caribbean and eastbound towards West Africa. So one of the most interesting outcomes of our research was that actually changes in the ocean currents and winds are the main contributors in the interannual variability of sargassum in the tropical Atlantic, rather than warming or changing in the river inputs. Especially these changes in wind patterns and ocean currents are strongly linked with a natural oscillation of the tropical climate. So there is a mode called Atlantic Meridional mode, where the convergence zone actually shifts both either northward or southward in the equatorial region. So we identified that when we have years with very strong sargassum blooms, these years corresponds to a negative phase of this natural oscillation, where the sargassum accumulated in the intertropical convergence zone is shifted southward, so towards the sources of nutrients, the Amazon River and the equatorial upwelling. So we have a stimulation of sargassum growth during these years. Of course, together with this interannual variability, we have a very strong trend in the sargassum biomass within the tropical Atlantic. So we can see a very strong trend with much larger sargassum blooms, especially during the last 5 years. So we have already an environmental change with increasing nutrients from the Amazon River, mainly due to the accelerating rate of fertilization and deforestation in Brazil. So we're expecting much higher nutrient inputs to the equatorial and tropical Atlantic in the near future. So we're expecting negative implications, socioeconomic implications for the local communities, both across the Caribbean Sea and West Africa.